Hello everyone, this is Manish from the ERA team. In this video, I am going to talk about how you can use ERA to provision a highly available Postgres database. When you install ERA 1.1 or upgrade an existing installation to ERA 1.1, ERA creates a new software profile for you called the Postgres 10.4 HA enabled OOB. As the name suggests, this is a software profile based on the Postgres 10.4 version. It contains all components needed to provision a highly available Postgres cluster. Let's go ahead and provision our highly available database. When I click on the Provision button, I am presented with two options: Single Node Database and Cluster Database. For highly available Postgres, I am going to choose Cluster Database option. When I choose the Postgres engine, ERA tells me that it uses Petroni to enable high availability for Postgres databases. Petroni is an open source software which is used to manage the cluster provisioned by ERA. ERA also tells you that the standby databases will be hot standbys and they will use asynchronous commit mode. On the database servers page, we are supposed to choose the number of nodes we want in our cluster. You can choose up to 5 nodes in the cluster. I'm going to leave it at 3. The next question is about the Petroni cluster name. This is the name that Petroni uses to administer the provision cluster. The database server name prefix is a string which is used to generate the names of the virtual machines in this cluster. I'm going to choose the Postgres HA enabled profile as the software profile, the desired compute profile, and for network profile, I am going to choose Postgres static network. This is a network profile that I have created from a static VLAN with IP addresses maintained inside ERA. When you choose a static network profile, ERA can reserve a virtual IP for you to act as a single endpoint of connection for the cluster. With ERA 1.1, you can also select a database server time zone, which is reflected in all the virtual machines that we provision. I'm going to leave it as the default. I choose the public key for access of the virtual machines. As you can see, ERA also has the ability to provision the HA proxy software on independent virtual machines. When you choose a static network profile, ERA provisions 2 HA proxy servers and also configures 2 ports for you. One is the read-write port. Any traffic to the read-write port is directed to the master node in the cluster, and the other is the read-only port. Any traffic to the read-only port is distributed between the hot standby nodes in a round-robin fashion. On the database page, we provide the database name, and the required Postgres password. I choose the built-in default Postgres parameter profile, and I leave the port for Postgres as the default. I provide the required size for my database. We also have an option to provide pre-create and post-create scripts which execute before the provisioning and after the provisioning. On the time machine page, I am supposed to choose the SLA and the schedule for my time machine. For this demo, I am going to use the newly introduced Brass SLA, which does not have a continuous recovery region and only takes 1 snapshot per day. With ERA 1.1, we have an API equivalent button which gives you scripts in various programming languages that can come very handy during automation. Let us go ahead and click on Provision to provision our highly available database. As you can see, a new operation has been triggered to provision the cluster. Once the operation is done, we can go to the databases page to see the status of the provision database. As you can see, under the database server style, there are 3 virtual machines because we chose 3 nodes in the cluster. Under the HA proxy server tile, you can see that ERA has provisioned 2 virtual machines for you with the HA proxy software. ERA provisions 2 HA proxy software to maintain high availability of the HA proxy itself. ERA also reserves a virtual IP for you, which can be used as the single point of connection for the cluster. This virtual IP floats between the HA proxy servers. If one of the HA proxy servers is not available, the cluster still remains operational because the virtual IP gets bound to the another HA proxy server. When you click on the description of the connect details of the database, you see the names of all the 3 Postgres nodes as well as the virtual IP listed under the HA proxy section. You also get to see the read-write port that you chose and the read-only port that you chose. HA proxy software by default exposes the status of the HA proxy on the port 7000. You can visit it on the web page and see the status. As you can see, we have exposed 2 proxies, one of which is redirecting all traffic to the master as shown by the green highlighted line, and the other proxy is redirecting traffic to the read-only replicas as shown by the 2 green lines here. Further details about the database and the time machine are available on the databases page. For more details about Postgres provisioning, please refer to the ERA user guide. Thanks for listening.